And Brent, you might as well stay on because it's your turn now. So
Okay.
Brent Summerville from NREL. He's a distributed wind energy system engineer from the US. Yes, we can see. Perfect.
Hi, everyone. Thanks. Good afternoon. I
Sorry
hope you're
for the
having,
delay.
oh, that's okay. No problem. I hope everyone's having a good time uh, and at the Folkecenter. I visited there in 2019 and I think it's a really nice place to visit. So I wish I could be there, but thanks for having me virtually. Quick update on MT2. So I'm the convener of IEC TC88's maintenance team for the IEC 61400-2 standard, which is currently in the process of being revised, working on the fourth revision of the -2 standard. And so we are under the revision process is underway. The current -2 standard applies to electricity producing wind turbines currently up to 200 square meters of rotor swept area. For actual turbines, the EOCycle 25 kilowatt machine, their S series, is about 200 square meters rotor swept area. So in modern days, it's around 20 to 30 kilowatts is the upper limit here. And of course, the standard covers the details of how to design, get the design loads and do the mechanical engineering on the design of a wind turbine, as well as some testing of turbines. So we spent a lot of time in the early part of this revision process considering input from the global distributed wind community, mostly brought together by IEA Task 41 to consider an increase in the scope of this standard because there are turbines that fall outside of 200 square meters that the industry felt should fall within our standard. So we worked on that for quite a while and decided to increase the scope of -2 from 200 to 1,200 square meters of rotor swept area. And we established three size categories of micro, small, and medium, where small is essentially very similar to the existing -2 scope. Medium,
I want to turn this off.
Kindle, we heard that. No problem. And medium is that turbine is currently living in an annex in the -1 standard, limited to 1,000 square meters. And so we're bringing it into our standard and bumping that 1,000 up to 1,200 to capture a passive yaw 300 kilowatt machine that we felt should fall within our standard. And then micro is probably up to about a kilowatt or smaller, and we put that category in so that very small turbine could have specific requirements. This also, the scope of work was to work through the whole standard in light of this expanded scope and new size categories that was approved in April 2023 by TC88. MT1, the maintenance team for the -1 standards, okay with us taking the medium wind folks into ours. And we've been meeting regularly with a target of reaching the committee draft or CD stage in November of this year. We realize these are the standard recommended timings from IEC. 18 months after kicking off would be a standard target for a CD, and then 2 years to resolve comments and get to a final standard after 3 years after kickoff. There's quite a bit of work with our expanded scope. So we are conscious that we may not meet this November goal, but we're pushing forth regardless. I'm serving as the convener, and Joe Sposi has been serving as our secretary for the whole time. I do want to congratulate Joe for winning this year's IEC, I think it's called the 1906 Award, for really his hard work in helping keeping us organized in this effort. We have 39 experts from around the world and Europe in Asia and the US. I would say about good coverage of certification bodies, test labs, OEMs, consultants, but I think about 50% of these folks are actually active. We'll have usually 15 to 20 in our virtual meetings. We had quite a bit of work in 2022 and 3 in preparatory meetings, trying to really nail down the scope of the standard and expand it and get that approved. But we've been meeting regularly, virtually monthly, since May of 2023. I presented last year in September at this conference, and then a whole another year has gone by. We've met 16 times since kicking off. We meet at a certain time where it's really early for some people, just right for Europeans, and really late for folks in Asia. So quarterly, we have double headers where we meet 2 times in one day, so we can try to increase participation. Of course, we try to do a lot of work in between meetings, and then just receive updates and hold discussions in these short 2-hour virtual meetings. But we're everyone's busy, and but progress is being made despite that. Some highlights of what's going on in NT2. First of all, we're changing the name of the standard from wind turbines Part 2 small wind turbines to micro, small, and medium wind turbines, so that we are encompassing all 3 of these size categories within our standard. On the field testing side, we took a hard look at the duration test. We've done studies, and it shows that this test takes a long time, thus costs a lot of money and mostly time, and presents a pretty significant barrier to market entry. So we are currently proposing that we change the duration test to more of an operational test that demonstrates the expected autonomous operation of the wind turbine over a range of wind speeds, removing a lot of things like power degradation study and dynamic observations, and really boiling it down to letting the turbine run on its own in normal operation for at least 1,000 hours of power production, and capturing at least 10 hours of average wind speeds of 15 meters per second and above. And that couples well with the safety and function test that has a test plan to exercise all the functions of the particular turbine and demonstrate rotor and speed control across a range of wind speeds. So we think this operational test coupled with the safety and function test will be a shorter duration, but provide good value to the designers and they're seeking certification of their turbine. On the design side, we're really taking a pretty major overhaul of the Clause 7 within the standard. In light of our increased scope, we now have medium wind turbines, so we're borrowing a lot of the -1 standard, which is quite similar to -2, but has evolved to have more clear language around its design load cases and some other helpful ideas that we're borrowing. And we're also adding additional guidance for vertical axis turbines and other novel designs that don't fall within sort of the normal archetypes. On the simplified load methodology for determining or estimating loads, we're really working hard to incorporate the changes as recommended by Dr. David Wood in that report there. And then in the simulation modeling method for determining loads, again, we're incorporating much of we're planning to incorporate the DLCs from -1 in general. They are very similar to -2, but add a few more and maybe a bit more clarity. But we don't want to just keep adding more DLCs. We want to make sure we are requiring folks to model or to estimate loads from at minimum the design driving DLC. So we do have a survey out right now that I'll drop into the chat. if you're a designer of a wind turbine, you can put in what your design driving DLCs or design load cases were for your major components. For example, the extreme parked design load case usually causes lots of thrust loading, and therefore drive is the design driver for your tower design. And then loads testing is not a third option for extrapolating to loads. It is loads testing is just going to be allowed or used for validating the model that was used, and we are planning to incorporate some guidance on minimum measurements for validation based on turbine size and archetype. Finally, on turbulence and inflow conditions, doing some harmonization there again with -1, like the assumed turbulence intensity for the medium class is probably going to be 0.18, which is what it is now in -1. Increase the TI for small wind turbines from 0.18 to 0.20 based on some research from IEA Task 27, and then probably have an even higher assumed turbulence intensity for turbines that are designed to be in a more turbulent environment, such as a rooftop turbine or other novel designs. So we wrote down a few potential research needs for MT2 we would share with this group. On the simplified load methodology, there's some assumptions there on yaw rate, and it's experimentally it's really challenging to measure yaw rates on passive yaw turbines. So we encourage any ideas sharing, any data sharing on yaw rate measurements for passive yaw turbines. We're also, as we look through the simplified load methodology, we realize that it could be a significant fatigue load case for active yaw turbines that spend a good amount of their time running in an off yaw position. So that could we could benefit from some research and load measurements on those types of turbines. And on air elastic modeling, basic research on load measurements for model validation and tuning is always welcome. What do you need to measure besides power and RPM to really get an air elastic model tuned up and validated? So it's always good to compare the loads from the simplified load methodology to modeling. We're looking at blade testing optimization in the standard, just getting started on that. So it would be great to learn about any lower cost blade fatigue testing. Turbulence, the turbulence subcommittee is always looking for field data to inform turbulence assumptions in the standard if available. On the new operational test, we're looking into the impact of changing from the current 10-minute averaging to 1-minute averaging. So that's a good math exercise for someone to help with. And then on modal analysis, I know Alex Herschel from Vienna did some modal measurements in the field to generate Campbell diagrams. And we also have air elastic modeling tools that generate Campbell diagrams for turbine systems. So that presents an opportunity for some validation between field measurements and model produced Campbell diagrams. Well, that's it. That's a brief overview of MT2. Please thank your country experts for participating and encourage them to continue to help us out as we move through this 4th revision. So thank you.
Thank you very much, Brent. Is there any question from the audience?
Yes, I have a question here.
Hi, Sven.
Please go
Hi,
ahead.
Brent. Thank you so much for giving us the update on the work. First question, you mentioned load testing only for model validation. Does that mean you're planning to remove the possibility for doing the load determination basically by testing.
Yes.
Yes,
Yes,
and there is no problem with that from people working with alternative designs where there might not be a modeling tool or simplified
Right.
equations.
Yeah, and
Personally, I would not personally be hit by that, but I was thinking about the vertical axis people and so on.
yeah, I think the thought is there still needs to be some sort of modeling that was done to couple with those load measurements. If it's purely load measurements that you're trying to extrapolate, that didn't seem to be a successful methodology. But if you couple those load measurements with really some sort of model, then that's the winner. So even so the vertical axis tool modeling tools have really advanced in the short term. And even if they're not really validated tools, it can still be coupled with load measurements to do their best job at estimating loads.
Yes, understood. And are you going to propose any changes on the turbine classes from before? I mean, the 1, 2, 3, 4, and S, and the consumer label.
I think we're keeping all those 1, 2, 3, 4, and S. So the only thing we're changing perhaps is some of the parameters around the classes, but I don't think we have any plans to add or remove any classes to that table.
Can you think of any proposed changes to the consumer label?
We're waiting. Basically, we've not discussed that much yet. I think we will have changes in light of the new scope of the standard and the changes to the duration test and things like that will ripple through to the consumer label. And so we've been waiting on Ignacio Cruz and his team to sort of bring that forth into the discussions, but we haven't done that yet.
Yes, thank you so much. And I was regarding the turbine classes thinking maybe it will add a new dimension if you have different turbulence levels. I'm sure it can be handled, but maybe it will call for some update anyway.
Yeah, maybe the turbulence doesn't change by class, but it will change by size.
Yeah. Thank you.
And you're welcome. Thank you, Sven. And then Niels has a question about is there any controllers for small wind turbines that can implement a Campbell diagram? In other words, control the rotor speed in such a way that it doesn't that it avoids critical RPM ranges. Yeah, I mean, I know that's employed in the field. The turbine designer understands from the Campbell diagram which rotor speeds will cause alignment with natural frequencies and will essentially build up some speed before it gets there and then rush through there and not dwell on those. So I do know that to be programmed into controllers anecdotally to avoid resonance. So the question continues about those classes. So a small wind turbine designed for high wind speeds is still category 1 or IEC class 1. Yes, and that will remain, and as will class 1, 2, 3, and 4. And if it's different than those, we still have class S for special. Thank you.
Thanks. And I believe Tony will also reach you out because he really wanted to see your presentation, but he had to pick up the car for tomorrow. So
okay, yeah.
Holdings, and then he will reach you, I guess.
No problem.
So thanks a lot, Brent.